last chapter, but now we're going to graph a system of linear inequalities. So it's kind of a combination of earlier in this chapter, everything we've been doing in chapter 4 so far has been solving a system of equations. And now this is going to be a system of linear inequalities. So really the only difference is it's going to be less than, greater than all of our inequality symbols. We're going to graph them on a coordinate plane, and then we're going to determine what the shaded region is. Okay, and we've done this before, but if I were to take this graph and shade it above, and then I were to take this graph and shade it below, then the answer to this solution is going to be, where are those two overlapping one another? And so my answer then would be wherever it's both blue and red, which would be that area right in there. Okay. So what, and we don't have, I didn't give you inequalities on this one, but each time they're going to give us an inequality. And we're going to say anything in this region would be an answer. So your answer is a shaded region today. It's not an ordered pair. It's not just one ordered pair. It's going to be a bunch of ordered pairs. And so anything that's in that green region would satisfy both of those inequalities. And we're going to talk about how we can determine that. So I'm going to do these on graph paper again, kind of like we did the other day. Okay, this first one is going to be pretty straightforward. I'm going to try to do these in different colors so we can have a better idea of what's going on here. So we've got two inequalities. We're going to graph them both on the same coordinate plane. We're going to shade them both, and then we're going to look for that overlapping region. Okay. So let's start with the one on the left. Let's start with the red one. Y is greater than 2x. What's my y-intercept assumed to be for this one? Zero. Yeah, if there's nothing there, then we can easily just say plus 0, right? So that's going to be my starting point. My slope is 2 over 1. So we're going to go up 2 over 1. And I can do that as many times as I want. I could also go down 2 and left 1 and make a bunch of points. I can make as many points as I want to. You know, a couple points is probably sufficient, but we can make as many as we want. Now, here's the other thing. We talked about graphing single inequalities in the last chapter. Now we're going to put two of them on the same graph. But after we make some points here, now we have to decide what kind of line we want. So we got a lot of decisions to make. If there's no equal to underneath, then this is going to be a dashed line. And greater than means it's going to be shaded above. Okay, negative 2x plus 4 is the second one. We're going to go up 4. Make a point. My slope is negative 2 over 1. So we're going to go down 2, right 1. And one thing to point out here too is we don't really care about the intersection point like we did early in the chapter. We had to really find out what that place where they crossed was at. We don't care about that today. Sometimes it might be a nice whole number where it crosses easy, and sometimes it won't, but we don't really care what it is. This one, though, will also be a dashed line. And then it's less than. So it's going to be everything underneath. Less than's below, greater than's above. Okay? And so then we're looking for anything that would be true for both of those. And you can make this darker. I'm just gonna do a different color here so we can kind of see what's going on here. So anything in that green region right there would be our answer. Obviously, this is not shaded at all. This is only blue, this is only red. Over here is where it's both blue and red. Okay, so that would be our answer. Our answer is that whole region. And what we're basically saying here is any point in this, any ordered pair in this green region would work. So I could, if I really wanted to check this, we've talked about checking a lot throughout the chapter. If I really wanted to check this, I could pick out one point, you know, like let's say negative 2, 0. And I could plug it in for both of these inequalities and see if it really does work. If we're not sure if we shaded it the right way or not, there will be some today that we have to check. And we talked about that a little bit last chapter as well. When it's in slope-intercept form, I think for the most part, it should be pretty straightforward on whether I shade above or below. But when it's in standard form is when we really have to check which way are we going to shade. Are we going to shade above or are we going to shade below? So slope-intercept form is not too bad. Okay, you guys kind of remember doing those before? All right, let's do another one that's in slope-intercept form, and then we'll do a couple in standard form. Okay, both of these are in standard form right now. And we did talk about the cover-up method, and cover-up method is okay here, but I think for this one here, doing it in slope-intercept form wouldn't be bad either. So you kind of got some choices that you got to make. Which way would you rather graph it? The only thing bad about standard form is you always have to check which way do I shade. So I'm going to change both of these to slope-intercept form, and then we'll talk about ones that we could do the cover-up method and what that would look like. All right, so let's do the blue one first because all I got to do is subtract x. Y is less than negative x plus 3. So I'm going to go up 3, down 1, right 1. We could also go up 1, left 1. Got a bunch of points here. And it is less than, so less than would be everything below that line. If you're not sure where to shade, the go-to point here would always be 0, 0. If 0, 0 is not on my line, I could easily plug 0, 0 in here. 0 plus 0 is 0. Is 0 less than 3? It is. So 0, 0 should be in my shaded region, okay? That's how you can check. If you're not sure which way to shade, check a point. Pick any point you want to, but 0, 0 is usually my go-to. Okay, now the one up here on the left, if I was going to solve for y on this one, what would be my first step? What are we going to start with? Subtract x. Yeah, get that x on the other side. So we're going to subtract x. Hey, now here's the part that's a little bit tricky, and I gave this one to you on purpose. I got a negative in front of the y. I got to get rid of that negative, which is kind of like a negative 1. I'm going to divide by that negative 1, and I'm going to do it all the way through that inequality. But when I do that, I got to be really, really careful here because now, when I have an inequality and I divide by a negative, what do I got to remember? Got to flip the sign. Okay, so this would now become y is greater than negative and a negative, make this a positive x, and negative 5 divided by negative 1 would be a positive 5. And that would be our inequality. And then we can graph it. We're going to go up 5, up 1 over 1, This is also going to be a dashed line. And it's going to be greater than. That's why you got to really be careful about flipping the sign. If I didn't flip the sign, I would shade in the wrong way, and I would be talking about a completely different shaded region. Okay, and so then we're looking for the area that's both blue and red again, and that would be this area right up here. All right, so slope-intercept form is a really good way to graph, okay? Especially if y is already by itself, but even if it's not, both of those were fairly easy to get y by itself. You just got to be careful if you ever multiply or divide by a negative. Bless you. Let's look back at slope-intercept form, standard form, and talk about what that's going to look like. Okay, so here's my two equations. Okay, both of them are in standard form. If you want to solve for y, you can solve for y. Okay, nothing against solving for y. Because these are both in standard form, I'm going to kind of remind you of the cover-up method as well and show you what this one's going to look like. Doesn't really matter which one we start with, but on the cover-up method, we plugged 0 in for x and found our y-intercept. Then we plug 0 in for y and find our x-intercept. All right, so if I plug 0 in for x, this would be a 0 right here. So I'm going to cover it up, and what I'm left with is 2y equals 6. Don't worry about the sign here necessarily. If I have 2y equals 6, 6 divided by 2 would give me 3. So my y-intercept would be at 3. Okay, then I can put 0 in for y. 2 times 0 is 0. So that would give me x equals 6. Make sure you put them on the right axes. 0, 3 goes up, 6, 0 goes over. Once again, we don't have slope on this one, so really we're just going to graph it using those 2 points. And it's a dashed line again. But I got to check it, okay? When I do standard form, I can't go off of this sign and say that's the way I'm going to shade it. Sometimes it works, sometimes it doesn't. So in this case here, I'm going to plug in 0, 0. 0, 0 is always my go-to. I mean, you can do any other point you want to, but I love 0, 0 because it's easy. When I plug in 0, I get 0, right? That's why it's so easy. 0 plus 2 times 0, still 0. 0 plus 0, 0 is 0 less than 6. It is, right? So what we did last chapter when we did this, we said 0, 0 is yes. So that's the way I would want to shade. If I said no, then I'm going to shade on the other side of the line. But it did work, so we say yes. Okay, then we're going to do the same thing for the other one. In this case, if I plug 0 in for x, I have 2y equals -2. -2 divided by 2 would be -1. If I put 0 in for y, 2 times 0 is 0, so I have x equals -2. Nothing to divide by. We're going to go down 1. We're going to go left 2. Okay, this one is going to be a solid line. Okay, what do I notice about those two lines? They're parallel, okay? When we had parallel lines earlier, we said there's no solution, right? That's not the case when we're shading. We're still talking about shaded regions. I still have to check a point here. So if I plug 0, 0 in, 0 plus 0 is 0. Is 0 greater than or equal to -2? And that's, again, a yes. So we're going to shade everything above the blue line. So we're above the blue, below the red, and so in this case here, it would be everything in between those two parallel lines, and that would be my solution. You could still have no solution. I could have something like this. Let's say I have two lines that look like this. Let's say the red one is above, and let's say the blue one is below. If those two lines are parallel, those two will never cross one another, right? So something like this would be a no solution, because there's no points that would work for both of those inequalities. And so, will that happen very often? Probably not, but it could happen. Most of the time, your two graphs will overlap at some point. Let's do another standard form. I'm going to do one where they're not parallel, just so we can see what that looks like and check it. Not really much different than the other ones that we've done. Okay, and I'll say it again, but I don't really care what method you guys use, okay? If you're really confident in solving for y and want to get y by itself, go for it. Just don't forget to divide by a negative. You got to flip the sign. If you want to do the cover-up method, that's fine, but if you do the cover-up method, you have to check. So there's kind of some things that you have to keep in mind, no matter what method that you choose. So let's do the cover-up method again, just so you have some examples of doing a little bit of everything. If I put 0 in for x, I'm going to cover it up. I have 3y equals 6. 6 divided by 3 would give me 2. So my y-intercept would be 2. If I put 0 in for y, I'm going to cover it up. Just gives me x equals 6. This one's going to be a solid line. Okay, but don't shade it until you check it, okay? When you do the cover-up method, you have to check. 0, 0 is the one I like to use. 0 plus 3 times 0 is still 0. Is 0 greater than or equal to 6? No, okay? So here I just write a no here. So if that point doesn't work, that means we got to shade the other side. So we shade up there. Okay, for the second one, still cover-up method. Standard form. Put 0 in for x. Negative y equals 1. 1 divided by negative 1 is negative 1. When you do the cover-up method, you don't necessarily have to worry about the less than greater than symbols. Okay, if I put 0 in for y, cover it up, I have 2x equals 1. 1 divided by 2 would be a half. So when I plot that one, we're just going to kind of estimate about where it would be. We don't have to be real specific with it. 0, negative 1 would be down here. 1/2, 0. Those 2 points are really, really close to one another. And once again, it would be a solid line. Okay, if 0, 0 were on this line, I really wouldn't want to use 0, 0, right? But 0, 0 is not on the line. It's really close to it, but it's not on the line. So we can use it, right? It's right next to it. 2 times 0, 0, minus 0 is 0 minus 0 less than or equal to 1. Yeah, okay? So here we would say yes. And so we want to shade on that side of the blue line. And then once again, we're looking for the overlapping region, which would be that area right there. Okay, last example that we're going to do. I'm not going to pull a piece of graph paper up for this one because I don't think we need it. X is greater than or equal to negative 2. Y is less than 4. Okay, we talked about these two equations. If I have X all by itself with no Y, what kind of line am I going to have? Be vertical, right? It's going to be straight up and down. It's only going to cross the x-axis, right? And it's going to cross the x-axis at negative 2. So it's going to be a vertical line, solid vertical line. Now greater than, just think about a number line. When I think about a number line, is greater than going to be to the right or is it going to be to the left? It's going to be to the right. Okay, so we want everything to the right of that black line right there. Okay, y less than 4. So x all by itself is a vertical line, so y all by itself only crosses the y-axis, and it's going to cross it at 4. So we're going to go up 1, 2, 3, 4. But it's going to be a dashed line. And it's going to be below. And then once again, we're looking for where both of these are shaded at. So it would be below the red, to the right of the black, and that would be our shaded region. Okay. If you want some graph paper, I'll get you some graph paper for today. You don't have to grab some. It's totally up to you.